Good morning all, new PCBs from JLCPCB. So without further ado, let's open the box and take a look at what's inside. Well, it's a fairly anonymous looking green 1.6mm PCB with a hassle, what's that, hot air solder leveling, I think it is, finish. That's the silver finish. Let's get these boards out of the bag. Now I only had 5 made, only really need 1, but this board could be quite fun to play with because it's just really a signal generator. It's a square wave oscillator with variable pulse width. Now this is the slew rate board for my vocoder project, but all it is a simple dual 555, it's actually a 556 chip, which I don't have, so today could be quite fun because I'm going to try and bodge together a 556 out of 2 555s, and it produces a square wave oscillation, I think at about 1 kilohertz, and the frequency is fixed despite there being a pot here. The pot actually varies the pulse width, so it's an astable multivibrator followed by a monostable multivibrator. So let's take a closer look at this board using today's JLCPCB magnifying glass, which is intelligent. Zoom in a little bit for this. Well, actually, we don't need the magnifying glass just yet, unless I get to something we want to see in real close-up. So as I say, there's a 556 dual 555 timer on here. Lots of capacitors, resistors, diodes, a couple of transistors because the output is buffered by these transistors. There's a JST3 pin here for the power input, that's 12 volts ground and minus 12 volts. Full size potentiometer there. And on the back there's something quite interesting. We've got a split ground plane here because this section of ground plane is 0 volts on the 12, 0, minus 12. This is a kind of different, separate floating ground plane. So here's the circuit diagram of this board. This is the 556 chip, it's 2 555s, and I think they're pretty much, one of the 555s is on one side and the other one is on the other. Now this diagram doesn't give much away because it's sort of not laid out conventionally. But the output of the second 555 is buffered with these transistors to swing this output between, well, what he calls plus 11 volts and minus 11 volts. But we'll have another look at that in a moment. Here's the split ground plane because this is the 12 volts ground and minus 12 volts. And this is passed through some low value resistors, 47 ohms and 220 ohms. And then smoothed and then sent off to the various parts of this circuit. Now he's referring to it as plus 11 volts, 0 volts and minus 11 volts. That's because there is going to be a tiny volt drop across these resistors. But that's not really the point of this. The point of this is because this uses 555s, which are very noisy components. And in a system, this vocoder, which is almost exclusively analog electronics, noise like this at 1 kilohertz is highly likely to get into analog parts of the circuit and you'd hear it. So these are really decoupling. This is a decoupling system. So any spikes on these 11 volt and minus 11 volt lines, they're nominally 11 volt. In fact, you'll probably find they might measure 12 volts the same as this. But these are smooth, decoupled by these two capacitors, and also decoupled by these resistors. So any movement here is not going to get through to the 12, 0, 12, as much as it would if these were just wire links. Now this circuit diagram is not going to be very helpful because the component part numbers on this circuit diagram don't bear any relation to the component part numbers on my circuit board because I redrew the circuit. So actually probably what I should do is print out my schematic for this from EasyEDA, and I can work to those numbers in order to work out what the values of all these components are. Let's get started putting them in and try to get this thing to produce some sort of oscillation on the oscilloscope. As I say, we've got a bit of an issue here because I don't have a 556, so I'm going to stick 555s in some of these pins and have hideous wire links to make this operate as a 556. So this is my schematic that I drew up on Easy EDA. 12012 comes in here. I've put an additional couple of decoupling caps because I've done that next to the JST on all my boards. Here are those 3 resistors to decouple the whole of this oscillator circuit, and 2 more decoupling caps, larger values here to keep this as stable as possible so that it doesn't get out onto these power supply lines. The layout of this 556 is even worse actually than the layout in the original magazine article, because here the pins are just higgledy-piggledy everywhere, but I'm pretty sure the low numbered pins are the first stage, which are the astable. The output from that goes through a resistor and a capacitor to the trigger input of the second stage, which are the higher numbered pins, the pins across the top of the chip, and that works as a monostable with the potentiometer here. It's 1 megohms, I think linear, and that controls the timing of that monostable, so that controls the pulse width of the output. And I don't know whether the pulse width goes full to 100% or full to 0. We'll find out when we put this on the scope. But let's get some of these components into the board and see if we can get at least the first stage of this running, which is the astable, where we should get a square wave coming out. So first things first, a socket for the 556 dual timer. It's 14 pins. Now 2 555s is 16 pins, but the 2 halves of this share VCC and ground. In fact, it's just literally 2 555s with their VCC and ground pins commoned up. So we need 7 for one side of my socket and 7 pins for the other side of my socket. Okay. Right, to get this to sit in there while I solder it, I want a random chip, 14 pin. This is actually a 74LS00, not relevant to this project, but it's got splay. Random chip with pin splay. That means that these socket pieces are going to be held out at an angle, and that means that when I poke this in the board, it's going to sit there under its own friction while I solder it. Okay, too much splay on that, and it was just sort of, the socket pieces were bulging out. So I'll reduce the splay a bit, shove it back in, solder it. So just while we're looking at the underside of the board, as I get my iron warmed up, as well as that split ground, you can also see there's a socket on the bottom, and that's because the pot mounts on the top, and there's actually a stereo jack socket for the foot pedal which mounts on the bottom of the board. So I've put the silkscreen for P3 on the underside of the board. Okay, let's get my socket soldered in. So let's solder in the 14 pins of this chip. Pin 1, pin 7, which is ground, that will take additional heat to get that to flow into the hole. Pin 8 and pin 14, which I believe is VCC. Yeah, pretty sure it is. 7 is ground, 14 is VCC. Why does that go to pot center? Oh yeah, that's right, because the pot's not an audio pot, it's a pulse width pot. So I guess that's fine. I don't mind having my 74LS00 in there while I solder these. It's going to get a bit hot, but I got plenty of those chips. Yes, it obviously did get a bit warm because the blue tack goes quite soggy when it gets hot, and that's ripped off onto the surface of that chip. But it's relatively easy to clean that up. Just get a bit of blue tack, dab it over the sticky blue tack, and as it all cools down, it kind of all solidifies again. So that's the socket. Is that warm? Yeah, it's quite warm. That's the socket in place. Now here's the thing. Here's the 555, of which I've got 2. Here they are. And here's the 556. Now you'll notice that 0 volts trigger output reset are mirrored here. 0 volts trigger output reset. So I should be able to plug these 4 pins into these 4 holes of my socket, and then with the chip sitting up sort of vertically, and then it carries on. Control I can bring round to there, that'll fit in there. Threshold I can bring round to there, that'll fit in there. Discharge bring round, so I can loop the top pins so they come round and sit in these pins. So it's actually laid out pretty much like the 555, but with all 7 of the 8 pins along one side. The only anomaly with this is I'm going to have to reach over to the other side to get the 4.5 to 15 volts. Now that's the thing, if the 555 can only take 15 volts, it can't take the 22 volts that's across my plus 11 and minus 11. In fact, it's going to be more like 24, I think, the plus and minus 12. And in fact, it doesn't, because you've got plus 11s on various pins. I think 2 of those are the resets, but one of them, pin 14 here, is going to be VCC. Ground is on pin 7. There are various grounds and plus 11s, but there's no mention of minus 11 here. The only time minus 11 appears is at the final output to get this signal to have a 22 volt, or probably more like 24 volt swing from top to bottom of the square wave. But the 555s or 556 basically runs off 12 volts. So bending the pins of the first of my 555s right out flat against the body of the chip. Actually, I'm going to have to bend the other pins, I think, out so that this thing is completely flat. It's not quite completely flat, so that it pretty much looks like that. It's looking a bit like a surface mount chip, but that does mean that pins 1, 2, 3 and 4, with 1 being 0 volts, can actually fit into 7, 6, 5 and 4. So that chip is going to sit in there like that. Weird. And now I'm going to use cut-off component legs to connect the remaining 3 pins here onto 5, 6 and 7. So they're going to sort of loop round. I might trim these pins down to make this work. So I'm going to solder pin 5 of my 555 on there. That's made pin 3 of my 556. So pin 5 control, pin 3 control. Yeah, that looks right. And now pin 6 of the 555 threshold going to pin 2 of my 556 threshold. You can't see that, can you? Pin 6 of the 555 threshold becomes pin 2 of my 556 threshold A. And this wire discharge A, pin 1 of the 556, pin 7 of the first 555. Now this last pin of the 555 is going to be VCC, so that's got to jump right over to the other side somehow. So what I've made is this, which turns a dual inline 555 into a kind of single inline 555. Just need to get VCC over to the VCC pin, but I don't really want this in the board now while I fit the other low profile components. I'm only going to fit the ones that relate directly to the first stage, which is the astable oscillator. Then we can get on the scope and see whether we've got a square wave coming out. So pin 1 discharge goes to R16 and R17, both 15K. Let's get them on the board. Here they are, both 15K, and they both connect up to pin 1, which is why I put them there. Let's solder these in. None of these goes to ground, so shouldn't have any difficulty filling these holes with solder. Quite large holes, so they take quite a lot of solder. They could be smaller actually, but it's the standard resistor in the library. But yeah, those holes are quite large. Right, what's next? Pin 2 goes to the other side of R17, also goes to C5, 33N. There's some danger of burning on my soldering iron. There's C5, it's right adjacent to pin 2, 33N. Let's see if I've got one. 33N is 333. That's a 333. I can't focus on that, but anyway, that's a 33N, 333. Now I do believe that's all we need to actually get the oscillator running, the astable multivibrator, because you have a capacitor going to ground for the timing and 2 resistors setting, well, also the timing. So I believe that's it. There's also a capacitor in here which goes to also to ground, but I think that's just on the control voltage input, pin 5 on a 555. So I'll fit that one as well. The equivalent of pin 4 reset is tied high. That's already done as a track on the board. So yeah, I'll just put that capacitor in to stabilize the control voltage input, and we should be able to get a signal out of this thing. So I put the chip back into the socket. Now the only other thing we need is VCC for the chip. Actually comes out of that pin in the socket. So I've just got to bend that and route it over to that unconnected pin up there. I'll just do that. Well, there it is, that blue wire running into pin 14, which is the VCC pin. Now, of course, when the other 555 is bent into shape, it's going to sit on these 4 pins because of the correlation again between VCC discharge threshold control, VCC discharge threshold control. So that chip will sit in those 4 pins, so I'll need some sort of alternative to this blue wire running across there. It's going to have to actually run down and solder onto the pin that's sitting in that hole. Yeah, it's all starting to look a bit bodgy. Now to power this up, I need to put, I'm going to put the JST connector on there. I'm going to fit these resistors, which are the 3 resistors that isolate my 12012 power supply here from the what they're calling 11011, or the 555 positive, 555 ground. Now 555 negative, or sort of minus 11 volts as they call it here, is actually only used at the output. So just to see the oscillation of the first stage, we don't need that. We only need 12 volts and ground. So I'll just get some batteries for that power supply. So the low value resistors are 220 ohms, and this one 47 ohms. Let's turn it so it's the right way around, which interestingly is 470, and then a gold band, which actually means 10 to the minus 1. So divide by 10. So 470 divided by 10 is 47. So that's 47 ohms. But the gold band is not a tolerance band. It's actually the multiplier. This middle resistor is going to be the hardest one to solder of all, because it's actually connected to the ground plane on one side to the ground plane on the other. It goes from ground plane to ground plane. So they are both spoked holes. Oh, that's not too bad. And this ground plane is a small ground plane. Oh, that doesn't mean it heats up instantly, no. So yeah, ground to ground. Weird. I'm also going to fit this R19 down here, which on the schematic is this resistor here, which comes out of the output of the first stage, just so that I've got a little test point to hook my scope onto so that we can see that output. So I'll just put that in. And I've also added that 100 picofarad capacitor that follows the 1K, because I thought I could get the scope probe on there, but actually I can't. So it'll go there on the 1K, or maybe even on the left hand side, directly on the output of the 555. Right, let's see if we can rig up some power on this JST connector. Well, I'm all set up with the oscilloscope, and this, I've got my probe on that 1K resistor, so we're looking at the output. Got a 12 volt pack of Eneloop light cells here, 10 1.2s, that's 12 volts. Let's plug it in and see whether we get anything on the oscilloscope. And we do. I'll just have to tilt the camera ever so slightly to see that, and I'll get in a bit closer in a moment to look at the numbers involved. So here we are, we've got a frequency of 948 Hertz. Now of course that's highly subject to things like battery voltage. If I mess around with the battery pack, that kind of changes. We've got a peak-to-peak voltage of 13 point, well, whatever this 12 volt battery pack is, 13.3 it's saying. That might include a bit of noise actually. I'm not sure that I've got that much voltage on the pack. I could have a look, I suppose. Interestingly, it's not a 50% mark space ratio, but then I guess that's to be expected because on the circuit diagram we've got the capacitor to ground, and then we've got the two resistors, which on a 555 would be on pins between pins 8, 7 and 6. Now these are the same value, and that doesn't give you a 50% mark space ratio. I think the resistor to positive, which would be this one here, would have to be much lower in value to get 50%. So no, we're not getting 50%, but it doesn't really matter because in the next stage, this output from the astable, which is just the free running oscillator, is just used through a very low value capacitor to trigger the second stage, which is a monostable multivibrator. So we're only really interested in one of the edges, I can't remember which edge it is, to trigger this in monostable mode. But yeah, we're not really interested in having a 50% mark space. That's just not that important. Let's just check that battery voltage to see if it agrees with the scope. If I can do this. It's not far out. I'm getting 13.1. The scope's saying 13.3, so maybe it's aggregating in a little bit of the noise on that signal. Yeah, 13.1 I'm getting on the battery. Now, nothing is adjustable here. The potentiometer on here varies the time delay in the second stage, and I'm not sure I've got time to do that today. I've kind of blown my time budget a bit, fiddling around with this chip and everything. I can probably influence the frequency a little bit if I put my fingers near these two 15k resistors. I can't do much with it. But yeah, so there's nothing really I can adjust, but there it is. We've got an astable multivibrator, in other words a square wave oscillator, running on the first half of the 556, which is my 555 stood up on end, producing a 12 volt square wave. There's not much to say about it really. So I think I'll do a second part to this video where I put the monostable multivibrator in, and we have the adjustable with this potentiometer mark space ratio. Now, would you like me to bend this second 555 into a contorted mess to provide the other half of the 556, or shall I just go and buy a 556 from a UK seller so that it turns up within a reasonable space of time? I'll let you guys decide, but for today's video, that's it. Cheerio.